Today I will be presenting the unique changes we have made to our buggy for the Gold Challenge. Our main focus was on improving communication efficiency, reducing latency, and enhancing the user interface through a dedicated web server. We started by completely redesigning the GUI. Instead of using a basic serial interface, we moved to a dedicated web server hosted on the Arduino. The website is built using HTML, CSS, and JavaScript, and is served directly to the client from the Arduino. To enable real-time interaction between the server and the client, we use the WebSocket protocol. This allows for asynchronous two-way communication, which is essential for things like updating speed and state live without refreshing the page. The GUI displays key data, like the buggy speed in centimeters per second, total distance traveled, and the ultrasonic sensor readings. We also added a speed slider that lets the user adjust the buggy speed in real time. On top of that, we built a debug panel showing important information such as the ORA4M1 and the ESP32 loop times, as well as the April tag ID. The top right corner also displays the current state of the buggy. For example, whether it's turning left or right, or slowing down or speeding up. A new feature we're proud of is the path tracking visualization. By using data from the motor encoders, we calculate the distance each wheel travels. This helps us determine the change in steering angle, which we then use to calculate the buggy's X and Y coordinates. These positions are plotted on a HTML canvas element in the GUI, allowing users to see the exact path the buggy has taken. It gives a clear visual representation of the buggy's movement over time. Initially, we ran the web server on the main Arduino chip, but this caused major performance issues. The combined load of the Wi-Fi and web socket processing introduced around 100 milliseconds of latency, which is way too high for our application. To solve this, we took a completely new approach. We reprogrammed the firmware on the ESP32 S3 Wi-Fi module. This involved repackaging the Arduino firmware to re-enable the ESP32 USB CDC bridge, not a trivial task. By doing this, we offloaded all Wi-Fi and WebSocket tasks onto the ESP32. The Renesas ORA4M1 chip now focuses purely on the buggy's core logic, maintaining low latency and high responsiveness. The two chips now communicate via internal UART. So, to summarize, we built a responsive and visually rich GUI using a dedicated web server. We added live data tracking and a path visualizer using odometry. And we significantly reduced the latency by offloading network tasks to the ESP32. These changes have made the system much more efficient, responsive, and user-friendly. Thank you for listening.